The special web, or Web 3.0, is the web we've always dreamed of, and it's the one that we've seen in our science fiction films. It's now finally becoming our next reality. Versys has created software that can globally interconnect any AI, human, machine, or object and make any business, city, or country run more securely and more efficiently, and a World Wide Web of everything, the special web. Dan is the co-founder and the president of Versys. Hey Dan, love to see you again.
Great to see you, Julia.
In our last interview, we talked about
we clearly need some breakthroughs to help us evolve as a global community, and so this is what some of the basic idea is.
That's great. Let's start with why does the special web matter? Your book, The Special Web. And the vast applications
enabling citizens, big data, artificial intelligence, and the Internet of Things to finally work together for the benefit of humanity and the planet.
Today, I'd like to start with how Versys differentiates special applications from those who leverage 5G and IoT solutions for smart cities and factories, supply chains and logistics, airports and ports, etc.
Absolutely, Julia. Well, there's a really fundamental understanding, and once you get it, it all makes sense. And that is it better to have a computer application that sits all by itself and does something, or a computer application that can interconnect with other computer applications and share information and learn and grow? Well, clearly the second one is better. And we learned that clear back in 1969 when the internet was invented. Before the internet, we did have computer networks, but they were built by one company like IBM or Digital Equipment Corporation, and they didn't talk to each other. They were just a specific network designed to sell airline tickets, so like the Sabre system or something like that. And then someone had the idea of maybe we could create a protocol, a standard that all computers could agree to, and then they could all connect no matter where they were in the world. And that protocol led to the invention of the internet. And the internet from 1969 until 1994, that 25-year period, was just about connecting machine to machines. And then we could do email because it was a communication link between all the machines in the world. Well, it was amazing because no company owned that protocol. It was an open protocol, free for anybody in the world to use. It was a global standard backed by IEEE. And so now, today, from those first 4 computers at Stanford and UCLA and Santa Barbara and Utah, in 1969, to test the idea, they connected those 4 computers. And remember, there's no central computer anymore. This is just any computer connecting to any computer. From that moment, over the last 50 years, we now have 40 billion computers all over the world, all connected together, all exchanging information, talking and everything. That's the value of an open interoperating protocol. And so the same thing happened again in the early 90s. AOL was a very big deal. People were getting AOL CD-ROMs, and you could load them into your PC, and you could read the New York Times and the Wall Street Journal. But then they invented a new open protocol, HTTP and HTML. And with HTML, you could make a web page with a hypertext markup language and link it. And then with HTTP, all the pages could transfer anywhere in the world. And now we have, from those early web pages in 1994, over the last 25 years, we now have 8 billion web pages. And then Google can index them all, and they can all have hyperlinks interconnecting them. And we have almost like one single library now of all the information in the world. You can shop, you can learn, you can be entertained, all from these websites. And that's because there's an open standard that they all agreed to. So now here we are at this next 25-year interval. From 1969 to 1994 was 25 years. From 1994 to 2019 was 25 years. So last year, we released a new protocol called Hstp, Hyperspace Transaction Protocol. And that links instead of linking all the web pages together, that links all the world together. So now all of our buildings, all of our cars, all of our cities, all of our ports, everything now can all talk to each other. They all currently have applications, but they don't talk to each other. So there's a recent study that just came out from one of the big companies like McKinsey that said, we've looked at the current 300 smart city projects that are being attempted in the world, and basically they're failing for one reason. They don't interoperate. They don't have a common standard. And so that was a big breakthrough we did with the spatial web, was let's write a standard to allow people, places, devices, objects, all to now connect the way that our web pages connect, or the way that our machines connected from the original internet. So this is really a continuing process that's already been working, where you release a protocol for free that anybody can use, and then anybody can build a spatial application, and it'll talk to all the others. So over 25 years, we went from 8 web pages to 8 billion web pages. Now we'll go from 8 web spaces to 8 billion web spaces. And by that time, we'll have all of our cities connected, our airports, our ports, everything. And the world then can operate much more efficiently and have things like Google Analytics and hyperlinks and other kinds of things, linking them all together. So we're really at the beginning of another big jump, the way we were in 1994 with the beginning of the World Wide Web. Remember, 25 years ago, there was no Amazon, no Google, no Facebook, no Yahoo, none of these things, no Alibaba. They all came because the protocol unlocks the possibility. So now we've got a new protocol. There's going to be new companies like new Amazons and new Googles that will come along as well. So this is an exciting moment in history as this new protocol opens up these new possibilities.
It is exciting. In a presentation you shared with me, it says versus complements rather than competes with other smart city solutions. Would you please explain more about it?
Sure. Again, what we want is something like the way our body works. Mm-hmm. In technology terms, this is kind of called biomimicry, where we learn from nature how to design technology, because it works very well. When I eat food, I don't have to run a mathematical calculation and determine how much food I should send to my feet. The body naturally does all that. It has nervous systems and all kinds of things that coordinate and operate everything. So by having a common standard, we can now connect separate things in a city together. And so if you have an application that's dealing with energy, or with dealing with traffic, or dealing with safety, or dealing with logistics because things are moving in and out of cities. Well, now, instead of them being completely separate and not knowing anything about each other, they can now interconnect and share information among themselves. Suddenly, the city starts to kind of look a little bit like the human body. It's a big system. It's taking in energy. It's creating solutions. It's serving the people with various kinds of services. Well, now they're all interconnected. It's more like awake. It's kind of like intelligent. And so then artificial intelligence can operate very nicely in the city and help manage things. And so really this is a new world that an AI likes to live in. So this is really to help the relationship between the human and the AI be able to work together in a smart city, in a smart factory, in a smart port, in a smart airport, and have all of that start to work together the way the human body does.
Why does versus complement instead of competing with other smart city solutions?
So the protocol is free to use. So if you have an application, you can make it compatible with the protocol. So I might have had a very interesting a document in 1995 that I have, but it's on my desk, it's not compatible with the web. So if I take HTML, the programming language, and I have my document and I apply HTML to the document, now I've turned it from a digital document into a web page. Suddenly now it can be linked to all the other web pages and link up. So maybe I have now a digital application in a city that might be monitoring the traffic flows, or it might be cameras or other kinds of IoT devices, but they're kind of siloed in their thing. But now by making them compatible with HSTP, we complement what they're already doing, and now it interlinks with everything else. Or another way you could look at it, let's say that you have a warehouse, as an example. You might already have an inventory management system, but now you can take the Versus application and put it on top of the inventory management system. Mm-hmm. And now it spatializes the entire warehouse and kind of turns it into a computer game. So now a person would put on a pair of AR glasses, and the AI in the system can show them exactly, oh, you have to go in the warehouse and get these 6 things. Well, as they go and do it, the AI system is now, the new Versus system is connected into their existing inventory management system. So we complement it. And so then when the person picks up the cup to put it into the bin to ship to you for your Amazon order, that it automatically, the system notifies the inventory system, oh, we just put the cup from the shelf into the bin. And so it automatically updates the inventory, and it's much faster and more efficient than it was the old way that it was done. And so you see how it complements the existing system, and then the workers can get the work done in only maybe 60% of the time. So it cuts their labor time by 40%. So they're happier, everything is smoother, running faster, the company's happier, everything is more profitable. So, it's a big win.
That's great. Versus operates through 2 organizations: a non-profit foundation, the Special Web Foundation, which distributes Hstp protocol, and a for-profit corporation, Versus Labs, which builds special applications. What are the business models of these 2 organizations?
Great question, Julia. Yeah. So the Spatial Web Foundation, if we're going to have a global open standard that anybody in the world can use to interoperate, every port talks to every other port and other kinds of things, then we really want to follow the way the World Wide Web worked. The World Wide Web, when Tim Berners-Lee wrote the World Wide Web protocols of HTTP and HTML, he placed them in a nonprofit foundation. That way they couldn't be purchased by a private company. And that way they stay free to use forever. And so we said, that's a great idea. Let's do that. So then we give up control of HSTP, even though we wrote it. And then it becomes a nonprofit foundation with other companies and individuals all working on it to make sure that the protocol gets better and better every year. And then we formed a partnership with IEEE, which is the big standards body, which is backs the protocol of HTTP and TCP/IP. And so that way, if you're a company, you know that this isn't just some company out here making a protocol. No, this has been vetted and backed by IEEE, and it's being used at MIT and Yale on various science projects. It's being used by large corporations. So, okay, this sounds pretty good. We can use it too. And so the business model of the spatial web is exactly like the business model of the World Wide Web. And so you have the WC3 Foundation, and they pretty much make sure that the protocol is, we're learning about it. If it needs improvement, it figures out ways to do that. And so we let go of control of that. And that way a company can use it knowing that they're just like us. We use HSTP, they do too. We don't have an advantage. We're not secretly. It's not like an operating system where we can see everything. No, it's a free, open, global standard. Anybody can use it worldwide. So that's the business model of the spatial web. It's a nonprofit business. So then we build then applications that run on top of the spatial web. Yes. But then anybody can, because the spatial web protocols are open, so anybody could learn from them and compete with us. So we're a little bit like Red Hat with Linux. Linux is open source, and anybody can use open source Linux. But if you're going to run 10,000 servers in a giant server data center, and your Amazon Web Services or Azure or one of these big companies, you probably need more than just open source Linux. Mm-hmm. And so Red Hat came in and said, oh, cool, we'll write software to really make Linux more usable by governments and corporations and large organizations. And so we do the same thing. So we give away the protocols, but then we build tools in a way kind of similar to the way WordPress is for HTTP or in HTML. You can write a website in HTML. You don't need anything else. But it's much faster if you use WordPress and some templates. You can build a website in a few days and be up and running. And so we do that in Versus Labs. We build tools and SaaS models. So our business model is a little bit like Salesforce. So we have a big SaaS system that sits there, and then we have software developer toolkits. So you can take the toolkit and build any application you want, and then install it. And if you want, you can plug into our backend, and you get all of the support from our SaaS system, so that you can bring a product to market really fast and really inexpensively. And then when you're sharing SaaS fees, then the costs are pretty low to you as a developer. And that's why Salesforce has gotten so large, because the actual cost per company is very low. But when you have thousands of companies using it, then it becomes very profitable for Salesforce. So we kind of followed their model on the SaaS side of the house. So anybody can build their own applications, or they can use our tools and build applications. And, it's a pretty exciting new environment to play in.
That's wonderful. How will you scale your business?
Excellent question, because we are spreading worldwide. So if you look at the World Wide Web, how did it scale? It went from 8 web pages in 1994 to 8 billion web pages to now. And it turns out millions of separate people built those. Company that had to build all those web pages. So if it had been AOL, and they had to build 8 billion web pages, they would have to be a huge company with millions of employees building all those web pages. So that's the great thing about an open protocol. We can release our SDK, and let's say that you're a big logistics company that has warehouses in 50 different ports around the world. And there are big companies like that. You can just take our SDK and build your application and just plug right into our server. And so suddenly, 1,000 new warehouses just came online and connected to us without us even having to lift a finger. Mm-hmm. So we can scale very nicely by working with channel partners like Accenture and Deloitte, the big integration companies, Capgemini, or we can partner with companies that already sell software for airports or logistics or hospitals. And we just integrate our code with their code, and then their salespeople can go to their existing customers and say, oh, look at this new add-on we have. This now spatializes your hospital group, or this now spatializes your port. And so they go, oh, why would we want to use that? Well, it cuts your cost by 40%. Oh, yeah, we do want that. And so, then it's already integrated with the code. So they just go around, like one company we're working with has 5,000 customers in 70 countries. They already have their customers. They already have their salespeople. They're already doing tech support on their product.
In partnership with them.
We just partner with them and integrate our code with their code. Then their salespeople sell our technology to all of their existing customers. And we grow without having to scale so much. We still grow, but maybe we grow from 50 to 200 people instead of from 50 to 20,000 people. We just partner with these channel partners. So we have a number of channel partners that help us scale.
That's great. What's the ultimate goal for Versus? To sell it like Red Hat sold to IBM, or go public one day?
Well, usually whenever you do tech companies, those are the two options. And you don't really choose at the beginning. Do you know what I mean? You make a decision. For instance, Google. Google tried to sell Google for $1 million in the early days. They thought, hey, we got this algorithm, we'll sell it to Yahoo. And, we'll make some money, Yahoo didn't want to buy it. So then later Yahoo came back after a couple of years when Google was growing really fast and says, okay, now we want to buy it. And they, how much? Yahoo said, we'll give you $4 billion. And so, and that's a lot of money. I mean, definitely the Google team had to look at that. I mean, Google board talked it over and they said to Yahoo, no, we think it's worth more like $7 billion. And so then Yahoo was, well, we'll just take, instead of giving you the $4 million, we'll spend the $4 million and we'll just compete with you. We're Yahoo. We're big. We'll kill you, And so Google kind of went, good luck. And now, of course, Google went public and now they're worth hundreds of billions of dollars. So every company has these choices to make along the way, and you have to make them. Right. You're right. One of those two options will be available to us. Some big company will go, hey, we want to buy you for this money, and the team will look at it and go, is this a good price? Or we'll go, no, we think we can go public and continue to run the company ourselves. So that we don't know yet. That's still in the future. We're still a young company, so we have a long way to go.
That makes perfect sense. Thank you, Dan, for joining us. It's good to have you today.
Thank you so much, Julia. Great seeing you.